All right, today you guys are going to look at standard form to get a good understanding of that. This is the last form we're going to look at, and then we're going to have a day to kind of pull everything together. So I did create kind of a template for you if you would like to use that for this one. But at the same time, I would prefer if you kind of copied over into your notes what we already have here and then kind of fill in from there. Just where I wasn't here, I wanted to make it as user-friendly as possible. So standard form is going to be of the form AX plus BY equals C. Our A, our B, and our C are all integers. So those are all going to be some type of numerical value. And what's super important is that we can't have both A and B be 0. A can be 0, B can be 0, but they can't both be 0. Otherwise, that equation just doesn't work anymore, because then we lose all of the variables. This form is going to be super, super helpful for us when we are working with systems of equations, and I'm sure you guys have seen equations in this form for those of you that did those systems last year, especially with that elimination method. But for right now, it can provide us a nice little shortcut in graphing just from the y-intercepts, or you can simply rewrite it in slope-intercept form and graph from there. So just to kind of reinforce something we've seen before, our x-intercept, so where our graph crosses our x value, is always going to be the ordered pair x comma 0. And so my y value is always 0 for my x-intercept. For my y-intercept, my x value is always going to be 0. So I'm always going to have 0 for x and then some type of y value. And so when we're going to go ahead and we're going to determine in a minute the x and y intercepts, when we're determining the x-intercept, we're going to let y equal 0. And when we determine the y-intercept, we're going to let x equal 0. So for the y-intercept, we let our x value equal 0 because we know that ordered pair is going to have a 0 in our x. And for the x-intercept, we let our y equal 0 for the opposite. So let's take a look at an example. We're going to determine the x and y intercepts for the equation 3x plus 4y equals 12. So first I'm going to look for my x-intercept. So I'm going to let y equal 0. So I wrote out x comma 0 to remind myself. So I'm going to write 3x plus 4, and then I'm going to put in parentheses 0 equals 12. When I simplify this, 4 times 0 is 0, so that cancels out, and I'm just left with 3x equals 12. So x equals 4. So I get the ordered pair 4 comma 0, which I've graphed right here on the coordinate plane. To determine the y-intercept, I'm going to let my x value be 0. So now I'm going to write this as 3 times 0 plus 4y equals 12. So I just put 0 in for x. This cancels out because anything times 0 is 0. I'm left with 4y equals 12, so y equals 3. So because we're multiplying by 0, it really does make it quite easy for us to be able to just kind of cancel out one of our variables. Again, the big area that we're going to see these is with word problems. So I put an example on here that you can copy over. So it costs $5 for a child or a student ticket to the Great Gatsby and $7 for an adult's ticket to the Great Gatsby. The theater department earned $1,900 on opening night. So what's unique about these word problems is that we're actually given two rates of change. We're given the rate of change, we're given the amount per child's ticket, and we're also given the amount per adult ticket. So we kind of have two different situations going on that are related, but they're not necessarily dependent on each other. And so in this case, x is going to represent our child's ticket and y is going to represent an adult ticket. And so our equation is going to be in standard form. We're going to say 5x, because it's $5 for a child's ticket, times the number of tickets that were purchased, plus $7 for an adult ticket, times the number of tickets that were purchased, that equals altogether $1,900. So that's how we generate that type of equation. And then what we do from there is we say, okay, let's assume that, I have to look at my calculator. Let's assume that 100 tickets, if 100 student tickets were purchased, how many adult tickets were purchased? Or I guess I should say child's tickets. And so if I'm dealing with children's tickets, I look back at my variables, which is why it's super important that we define our variables. And we say, okay, I'm looking at children's tickets, so I'm looking at the X variable. I'm gonna let X equal 100. So I'm gonna do 5 times 100 plus 7y equals 1,900. And then I'm going to solve this equation. 500 plus 7y equals 1,900. I subtract that 500 and I divide by 7 to get 200. So I know that if I know there's 100 adult tickets purchased, that implies that if there were 100 children's tickets purchased, there were 200 adult tickets purchased. All right. Go ahead and fill in anything extra. I put a little something there for you just to a little reminder about what types of lines are horizontal, which types of lines are vertical. You're going to go ahead and complete the standard form problem set. You can check your answers afterwards, and then you can work on that Delta Math that was the test corrections from your Unit 1 test. And I will see you all on Wednesday.